So for the next minutes, we're going to talk about the input and output interface for the PicoBlaze microcontroller. We are going to start in this first video with an introduction and input operations. After this session, you should be able to explain the basic schematics for input and output ports, relate the input and the output interface with their operating mode, and explain the input and output timings and operations also. We're going to start with the basic schematics for the input and output ports, which you can see in the picture. We have an in port that captures input data during input operations. We have an out port that presents output data during output operations, a read and a write strobe that are set high on the second clock of the 2-clock cycle instruction. The read strobe works for input operations and the write strobe for output operations, and this happens because on the PicoBlaze every instruction executes in 2 clock cycles. We have a clock and a reset input and also an interrupt input and output. The port ID we are going to see a little bit further in this slide. So it provides the port identifier number or the port address for both input and output operations. It is available for 2 clock cycles, providing enough time to decoding logic or to connect to a synchronous RAM. The input and output operations support both direct and indirect address. Direct address means that the port address supplier is an 8-bit immediate constant, and indirect address means that the port is specified as the contents of any of the 16 data registers inside a PicoBlaze. The addition of peripherals is possible, but it requires a way of decoding the port ID value using the minimum required logic. We are now moving on to talk about input interface. Input port can be classified as continuous access port, which we're going to see now, or single access port, which we are going to see further in this session. So continuous access port means that the data is presented continuously, and so we are going to analyze this block diagram to see how does it works. The port ID output, that can be a constant or a register, selects the desired input, which means that the input sources are selected via a multiplexer, where the port ID is the selector input, right here. Also, this multiplexer has a size proportional to the number of possible inputs available. In this case, we have 4 inputs. After the selection of the input, the corresponding data is going to be transferred to the in port, and after that is going to be again transferred to any of the 16 data registers available inside the PicoBlaze. The input operations has certain time that we are going to analyze now. So input instructions reads data from the in port, and it can be coded in these 2 ways. The first one means that the data is going to be read from a register, in this case the SY register, and the second one means that the data is going to be read from the port, which the name should be specified in port name. Now, looking at the graphic and following the input interface operation we saw in slide 5, we can be that the port address is defined by the contents of the register S7, which we can see in the port ID line, and that selects where the data is read from. The port ID is then decoded, and the requested data is going to be presented on the in port, and the red strobe signal goes high on the second clock of the 2-clock cycle instruction. And after that, on the third rising edge, which is the number 2 on the figure, the data is captured from the in port, which means the end of the input instruction, and is now presented on the register S0 inside the PicoBlaze, which was our goal from the beginning set here on the instruction. So, as I already said, the input can be classified in 2 ways. continuous access port or single access port. Continuous access port we saw in the slide number 5, and now we're moving on to single access port. On case of a single access port, the data is triggered by a single discrete event, such as receiving a character in the UART buffer, for example, and because of that triggered data, this interface needs a mechanism able to remove the data retrieved from the buffer at the end of the input instruction. So the decoding circuit decodes the port ID and the read strobe signals, and the decoded output, the signal RV, is considered as a removal signal, which is asserted for 1 clock cycle and which removes the previously retrieved data from the buffer. At the end of the input instruction, 1 bit of this 4-bit RV signal is asserted high, and the corresponding FIFO is going to perform a reading operation in which the first word is removed from the buffer.